Morning. Good morning. Good morning. All right, good.
Thanks for coming, guys. Just as expected in a Java session at Microsoft Ignite.
It continues to grow.
It's a packed room. The people on the camera can't see how packed it is. Welcome to the overflow room in the back. Yeah, I'm just kidding. Thanks for coming.
I would say we grew 400% since last time. You know, from 10 to 40, that's 400%. Thanks again for coming by. I'm Bruno Borges, Brian Benz. We are on the Java team on Microsoft Azure. And we want to share with you not only about cloud architecture, but also about Azure and Java applications on Azure and how things run, and provide you as many demos as possible and walk through some of the options, some of the services, some of the frameworks, technologies that you can use as a Java developer, as a Java professional, or someone who supports a Java team in your company. So, oh yeah, we have a keyboard. So the agenda for today, we're going to talk about cloud architecture, about deploying applications in the cloud. We're going to take a look at how to build, how to integrate it, and how to deploy these applications, and finally how to manage and scale. And through that, we're going to look at deploying simple applications, deploying Kubernetes applications, and using CI/CD tools, command line, IDEs, whatever you feel like you would have to get your job done. So the first step on cloud in general is to understand some of the elements of cloud architecture. I'm just going to provide a quick overview of 3 elements of a cloud architecture, but there are actually a lot more. In fact, there's this thing called 12-factor manifesto for cloud applications, called native applications. I think it's 12factor.net.
Yes, 12-factor. How many people are familiar with 12-factor applications?
Okay. Perfect. So I'll just highlight 3 of these cloud architecture elements. Some of them are related to the 12-factor manifesto, some are not, some are kind of a mix. But I find it interesting because there's a lot of buzz going on with these 3 of them, and one of them is circuit breaker. So who is familiarized with circuit breaker? Okay, perfect. So there is a pattern called retry. There is, you expect the service to work, so you just give it a retry. So such as a database connection. Sometimes the database goes down for a little bit, the connection pool gets lost, and then you're going to retry it. But for some reason, some services might actually fail and for a long term. So for that particular use case, you go the other way around. Instead of trying and creating this waterfall of failure in your system, you apply a circuit breaker pattern that will kind of measure how many attempts you made and the resource kept failing. So once you reach a threshold, you basically stop trying and you go to a different service, or you provide a message to the user and say, hey, you cannot try this anymore because it will fail. So that stops the cascading effect of your system and prevents your system from going down, basically. So it's a very interesting pattern that can be implemented in many ways, using many technologies and many Java frameworks. One Java framework that can easily implement this thing is Spring. On Spring, it can provides that capability right away with some extensions and some annotations. You can just put that right on your code. The other one is back pressure. So back pressure is, sometimes you have this resource. One example is, again, database. Databases are great examples on how things might go wrong. And the database might have a limited amount of resources and cannot process 200 users at the same time. So imagine one user triggering the system several times, and you really want to say, hey, that user particularly, please stop calling this API. Please stop calling this process, because this is slowing down the entire system. So the back pressure is a way that you can identify and provide limits to consumption of APIs and services. So it's also an interesting pattern to look into when you're designing your architecture and make sure that your system is reliable. And the third one is very common, actually. It's service discovery. And with service discovery, it's basically you have this registry, you have a way or a location to go to, and identify where those services are running. You have the name of the service, but you don't know where, or the port number, or anything. That's why you go to the service discovery registry to find out about that. One great example of a service discovery technology is DNS. It's actually very simple, and actually several teams use just simple DNS as a service discovery, but there are other technologies. Netflix OSS has a project for service discovery, and it provides other capabilities like load balancing within the service discovery registry. So these three patterns are good examples of things that you should really consider. I like these three, and Brian put together these slides in a way that we can understand why these are important. Because when in a cloud architecture, you have multiple services, you have multiple microservices that are talking to each other. And with these three patterns, at least these three, you have a more reliable cloud architecture.
Right, and it should be mentioned, there's several platforms that handle cloud-native functionality like this right out of the box. There's Red Hat OpenShift, Cloud Foundry, their actual container platform, Kubernetes to a certain extent, and also Microsoft Service Fabric. So those are definitely considerations when you're building this. You can just actually literally build your apps on top of them, and you can use things like Spring Annotations for Cloud Foundry, or just build into the operating system layer, the container layer, your failover, your back pressure, circuit breaker, et cetera. So a few things we want to cover today, sort of the theme of the presentation is the cloud native application lifecycle. There's several things you do. Generally, when you're moving to the cloud, how many people here have Java apps or apps that they've migrated to the cloud already from on-prem?
Who did migrations?
Just a couple, okay. So I mean, basically the standard way it goes, and there are exceptions of course, but the standard way it goes is you build an app, you try it out on the cloud, usually on a VM or a container, and then you start integrating that app with services. Like, for example, you might have a MySQL database or an MS SQL database, Postgres, whatever you've got on the back end. It might be running on a VM right now, MongoDB or Postgres or MySQL or et cetera. Might be on a VM and it's actually running. Now you want to actually take that VM, you want to get rid of the management overhead of that actual VM or whatever it is and move it to a service. So we actually have MongoDB services, MySQL services, et cetera, that you can actually integrate with. And we'll show some examples of how we did that in a bit. The next thing you want to do is you want to probably automate the deployment of that app. So you've got an app, you built it, it works on the cloud, it integrates with services. Now you want to actually automate that deployment. And we have tools for that. We have Azure DevOps. We have integration with Jenkins. How many people here use Jenkins? Okay, quite a few. That's what I thought. What about Azure DevOps? Less. Okay, so cool. I'm going to show you a couple of things later. The whole thing with Azure is to preserve your investment. So you've got Jenkins. That means you invested in Jenkins. You know how it works. You know the strengths, the weaknesses. You've debugged a lot of things, and you've got it running. You don't have to replace that when you run it on Azure. You can actually just use our integration. I'll show you some examples of Azure DevOps integration later. And the next thing you want to do once you've got your app running, you've got it integrated, you've got it deployed, automation for the deployment. You want to manage that app. You want to check telemetry. You want to make sure that the app is performing well, and you probably want to scale it. So we'll talk a little bit about scale. So what have we got to offer Java Cloud Native developers? This is basically our eye chart, and Cosmos DB has a MongoDB backend, so if you're using MongoDB. We have Service Fabric, as I mentioned before. It's a cloud-native architecture platform. You can run your applications. We have Kubernetes, of course. We have App Services, which is a simple way to run a jar or a WAR file. Just take it out and throw it on Tomcat on Azure, and you don't have to manage anything of the underlying operating system. Let's see, what else we got? App Insights. We're going to show an example of that. That's for telemetry. Now this crowd actually, usually we're used to talking to Java audiences, and they don't know a lot about the Microsoft services. I'm assuming you guys know more than than your typical Java crowd being here at Ignite. But we do also have a really good partnership with Azure Systems. We just announced a free OpenJDK that you can use integrated into all of your applications. We have it on our container instances. We have it on web apps and a few other things. It's already there.
Well, OpenJDK, as you know, open source, it's free, it's available. The question is really with the recent changes in Java release cycle that is updated every 6 months now with an LTS version, long-term support version, every 3 years. With that change, if you want commercial support, you have to go to a vendor to get security patches, updates, or backport updates backported to a version that you had already, such as the LTS version. So we did this collaboration with Azure Systems, where if you use OpenJDK binaries from Azure, the Zulu Enterprise version, on Azure, you got that commercial support for free on the LTS version. Right. So you don't have to go to Oracle or IBM or Red Hat or any other company that provides those commercial support. You just simply use Azure OpenJDK binaries on Azure, and you are covered with LTS support. That's granted for free.
And the other thing, if you're working with multi-cloud, we support Terraform. We also have, you might have heard this number, about 40% of our VMs on Azure are Linux already, and we support basically all the major Linux flavors. We also have Eclipse plugins, IntelliJ plugins, and I'll get to that in a little bit. That's a good overview, though. So build. Just wanted to drill down into some of those services a little bit. We have support for Azure Functions. In the Java world, we've actually built a Maven archetype that you actually build through an interactive process. You actually just trigger that with Maven, and it asks you a few things about your application. It gives you a base that you can build triggers and bindings into. Service Fabric, as I mentioned, has a Java API and a Java SDK. And it has a way of managing containers and microservices that run on top of those containers. And those could be multi-language. In this case, with Java, you could have Java apps. You could break it up into microservices, and then have those microservices managed on containers for you in a single pane of glass, basically. Azure App Service, we support Java 8 and 11, and Tomcat 8 and 9. We have a Maven plugin for that. Cosmos DB, we have a Java SDK, and I'm going to show you a little example of that in a bit. We use the MongoDB API, so if you have an application running in Java that accesses MongoDB, you just change the connection string and it works.
And one interesting thing on the Cosmos DB Java SDK, there are two. One is synchronous. It's just like JDBC. So when you work with the database, you have blocking APIs. So you cannot do anything until that call to the database actually finishes. The Cosmos DB original SDK was like that. And for cloud applications, for reactive applications, that is a problem, that is a challenge. So the team implemented a new SDK, new Java SDK that uses RxJava, and that provides an asynchronous reactive Java SDK. So that allows you to provide a much higher throughput of calls to your code that uses Cosmos DB in the backend. So the latency, it depends on your processing and how much your business logic takes to execute, but the throughput of the calls, of the amount of calls that you can process is much higher because it's all reactive in the backend, so you don't get all those threads blocked by the calls to the Cosmos DB API. So this is actually an interesting Java SDK to use if you really need that performance.
We also have App Insights, and we have general Java SDKs for accessing a bunch of services. And by the way, these are all open source. They're all on GitHub. They've been that way since the beginning. They're available. If you don't like the way it is, you can submit pull requests. If you find issues, we respond to issues as well. A little bit about Open Service Broker as well. Yeah. So recently, we joined the Open Service Broker initiative. We actually have Open Service Broker integrated with OpenShift. If anyone's going to be around tomorrow morning, I'm doing a talk with Red Hat. We're going to show OpenShift and Open Service Broker API inside OpenShift, connecting to backend Cosmos DB service and a few other things.
Yeah, and it's also available in Pivotal Cloud Foundry if you
Yes.
if you have that platform on your environment. You can go to the CF Marketplace Azure, and you have access to these modules.
And so the whole idea with Open Service Broker is that it's, you can use it technically on multi-cloud, depending on what your backend is. If you have a SQL Server or MySQL or MongoDB on the backend, you can use an Open Service Broker to actually connect to that in your app. You should be able to connect to pretty much anything that's standard that has adhered to the Open Service Broker API standard, regardless of where it is and what the actual backend is. So as long as it has that middle layer, should work just fine. It's built on an open standard, integrated with Helm. How many people here are familiar with Helm? Helm charts and draft. Okay, so we bought a company, Microsoft bought a company called Deus a couple of years ago, and it's Helm charts are an easy way to actually manage and deploy Kubernetes manifests. If anyone's ever tried to build a Kubernetes manifest from scratch, it can be kind of hard. So Helm is actually a way to build a chart that manages your manifests. Oh, yeah, so we also have, I'm going to show some examples in a bit, Visual Studio Code. We have a ton of extensions. Actually, we've partnered with Red Hat to build a Java support. It's not a full Java IDE. It's not going to replace your Eclipse or IntelliJ, but it is a quick, easy, light IDE. I actually like working with it a lot. You can work with and debug pretty much all the Azure services that we have through SDKs as well. And I'm going to show some cool things you can do with that in a bit too. We also have Azure DevOps Services extensions that integrate with Jenkins, with GitHub, Apache Tomcat, and other DevOps tools. So as I mentioned before, you don't have to give up. When you want to work on Azure and maybe you want to do something that's pretty cool in Azure DevOps, Azure DevOps is really good for a couple things. Number one, free private Git repos. So you don't have to pay for them like you do on other Git providers.
Like GitHub.
Like GitHub or GitLab or others. Also, it's really good at managing multi-language platforms. So, you might use GitHub for managing your Java project. You've got another repo for managing your C# project. This is a way to actually integrate those things. And I'll get into the details of that in a bit. I'm getting ahead of myself. We also have toolkits. How many people use Eclipse here?
Okay.
4 or 5? Okay, how about IntelliJ? Okay, more? Okay.
Right. Eclipse to this side. IntelliJ to that side. Anybody on that pings?
We have plugins for both. They're identical functionality. You can get IntelliJ extensions and GitHub plugins that allow you to deploy to containers, to web apps, and a few other things. And yeah, definitely check those out. You log into your subscription, and basically once you set up a few things, just right-click Publish, and it actually publishes out to Azure for you. Spring Boot starters. So how many people are familiar with start.spring.io? Okay, pretty much everybody. All right, I was going to show it, but I won't. Start.spring.io is a great way to build a Spring Boot app. And if you go down on the left, scroll down on the left in the advanced section of start.spring.io, you'll see some Azure support that we've actually got built in, and we actually have some more things to be added in the wings as well. So Spring Boot starters are a way to actually integrate a bunch of different jars in a package that we've actually pre-built for you. It's on Maven as well.
And not all of them are available on start.spring.io because for a starter to be available on start.spring.io, they have to be blasted by Pivotal. And we created a couple more, but they're still just on GitHub, not over there, because still waiting for Pivotal to blast them. But if you want to check them out, just go to the Azure organization on GitHub and you search for Spring, and you're going to find a couple more over there. One of them being for Application Insights, which is part of one of the demonstrations.
Yep. So I want to talk a little bit about Cosmos DB because I'm going to use it in several examples today. How many people are familiar with Cosmos DB or using it now? Okay, just a few? Good, cool. Cosmos DB is a multi-model database, allows you to, and what that means is you can actually use the same database facility for multiple different types of data. Table data, SQL data, NoSQL data, Gremlin. So this is just a little history of what's happened here. In March 2017, we added MongoDB. We've been enhancing that ever since. There's a table API for doing quick, Redis-style application storage as well. There's Gremlin. Cassandra is also added. And we actually have Apache Spark for doing streaming data, HBase, and we have ANSI SQL as well. And I'm going to show today the MongoDB API in a couple of apps. So just wanted to cover that for you. We also support everything else. So if you go into the Azure Marketplace and search Oracle, you'll see a bunch of different Oracle images. Some are pay-as-you-go. We also support MySQL. We have actually our own MySQL service that runs on Azure, scales automatically for you. Of course, we have Microsoft SQL Server, Postgres, MongoDB through Cosmos DB. We actually have DB2 images as well that you pay as you go or bring your own license. Yeah, we don't have Access yet, do we?
Yeah, Microsoft Access is not supported on Azure.
You guys know how to handle ODBC, though.
Yet.
Yeah.
You never know.
And then
manage service for Microsoft Access. Maybe.
Next will be Excel. And yeah. Anyway, so let me pop into a demo now. So what I'm going to do is, thank you, sir. This is Visual Studio Code. How many people here use Visual Studio Code? Cool. All right, okay, cool. Well, I've actually installed all the Java extensions on here and a bunch of other extensions that I'll show you in a bit. But the basic thing is, the first thing you want to do really when you're moving to the cloud is probably do something really simple. Like just get this thing running on a VM, right? So to build that in this particular case, what I used was an app called Spring Music. You can just search on Spring Music and it's going to pop up. And it's a actual Spring sample that you can get. I cloned the repo and I changed a couple small things here. The first thing I did was I just wanted to connect to Cosmos DB. All I had to do for that was create a Cosmos DB instance. Let's see, where did I do that? I used the Azure CLI to do that. And it's just basically, I don't have the code for that here. But I changed a couple of other pieces of code. Once I created the Cosmos DB instance, I actually just edited Mongo local config.java. I put in a straight standard Mongo API call, and then I went into my application properties. How many people are familiar with application properties in a Java app? Okay, so basically in a Spring Boot app and a lot of different Java apps, you've got an application YAML file or application properties file. And in those files, you actually change where the application points to. In the case of the Spring Music app, it was just pointing to a local instance of MySQL or MongoDB. So I wanted to set it up so it would actually point to Cosmos DB. In this case, as I mentioned, I changed the code for Mongo Client. And then I just changed the application properties to point to the right place. And if I go into my Azure profile here, this is the Spring Music Cosmos DB app that I built. I just went down to the connection strings. I won't click on it right now, but it will basically just show you the connection string that you want to use. You plug that into application properties, and then it runs. And the next thing I do, I actually just go into the app itself. And I just do a Gradle clean assemble. Yeah, just a Gradle W clean assemble. I already did that actually. So let me just, the clean assemble just builds it in about a minute and a half. And once you do that, then you can just run the jar file. And this is local. But then I could actually, this actually produces a, the Gradle clean assemble produces a jar or a WAR file. And you can take that jar or WAR file and deploy that out to a VM pretty quickly. You set up a Ubuntu VM using the CLI or the portal, and then basically run exactly what you're running here. So I'm going to show this running. There we go. It's up. Now, if I go to localhost 8080, this is the Spring Music app, and it's actually going and getting the data. It'll actually, the thing I like about Spring Music app is you can actually set from the command line. Let me show you that. From the command line here, you decide what profile you want to use. In this case, I used active MongoDB, and then it uses that MongoDB local. I can change that to MySQL, MS SQL, or a local database as well. In this case, it's pointing to that, and it will actually generate the data if I don't have it. And I actually went out, the default data was only 20 albums. I went out to Rolling Stone on Kaggle. How many people know Kaggle.com? Okay, nobody. Go out, this is cool. For test data you want to use, go to Kaggle.com. It has a ton of test data. So I went out and got Rolling Stone's top 500 albums. And that's what I've got here. It's in a JSON file. I loaded it in, and it automatically generates this and populates Cosmos DB if it's not there, or it just connects and displays it if it is. And then all I need to do, let's see, 1967. I can go into my portal here. I can just go Data Explorer. And it just loads the records under Albums, Documents. And here's the first record here. And you can see, let me just zoom that in a little bit. Pull this over. Anyway, you can see here over on the right, for those of you in the back, it's basically just showing the object, and it shows the Beatles 1967 record here. So let's go in here, and let's just change that. So running the Spring Music, I can just go in here, and I can just edit this, and it's 1968. Let's save it. It's going to tell me it's saved. I can go back in here, and I can open up this record again. And it shows 1968, yay. So basically, it just works with the Cosmos DB on the back end. Cosmos DB automatically created 3 replicas of this all over the world. By default, you don't have actual control over where those are, but you can control it with some paid subscriptions as well. But it's a fully robust application back end for your MongoDB apps, and it's ready and it's running there. So that's just a little bit about, was it 5? I'm gonna switch back.
The slides?
Yeah. So that's basically this MongoDB app running. Let me just shut that down. So that's a little bit about building it for the cloud. All I needed to do was take that file from GitHub, change that one class, and then change the application properties with the connection string I get from the portal, and all of a sudden I've got a MongoDB application running. It's kind of a handy way to get started. And that's typically the way people start building things. You're going to build it, you're going to try it on Azure, you're going to try and integrate to a back-end database, and then add some tools. Some other things you might want to do. So I mentioned integration. Things you can't do in a on-prem service or on a regular cloud service is things like functions. So how many people here are familiar with Azure Functions? Okay, a few of you. Okay, cool. Well, basically the idea here is you can create a function in multiple languages on Azure. It's got triggers, which means, I added a photo to a blob, that's a trigger. Or it can have bindings, which is basically I'm connecting to a storage, I'm connecting to Cosmos DB, et cetera. You build that app, you can execute it, and then you can actually deploy that out to Azure, either a web worker role or a Linux container, which is in preview right now. And then you can build in CI/CD to actually update and deploy those as well. And you can use App Insights and some stuff that Bruno's going to show later for improving performance as well. But actually, it's really scalable. The thing about functions, really, the bottom line is they're really scalable and they're really cheap. And you don't have to control scale. It'll actually be controlled for you, depending on the load that you have. And it's fractions of a penny for each call that get made. I've got a few teammates who've really built some cool things, and they're getting hundreds of thousands, if not millions of hits a month. And the bill they're getting is like $3 or $4 a month. So It's a really nice, economical, fast way to scale something that's really simple in an app. So just to give you an example of the kinds of things that functions replace, what are they good for? This is a question I get asked all the time. Let's say you want to upload a photo to storage and you want to process a thumbnail of that photo to be displayed somewhere. Before functions, you basically just set up a VM or a container or a web app. Then you have to build your app, you have to deploy it, you have to watch app events, use the Azure SDK to integrate with services, whether or not it's the Java SDK or any other language, and then build a scaling process to actually figure out how you're going to scale the VMs or the containers or the web apps. In this case, you just use the Azure SDK to connect to your services, and the functions takes care of everything else for you. So for that one, I want to show another demo. Thank you, sir. All right, so what we're going to do here, I'm going to switch over to Visual Studio Code, and I'm going to change my folder. Open folder, and we're going to go to Functions, Java, Computer Vision, Cosmos DB. All right, so what this does in Visual Studio Code, when you change the folder, it basically just changes a couple of things for you. It opens up a bash window by default, and this is the actual function code that runs the Java. So I'm going to run it first, and then I'm going to explain what actually is happening, because it takes a minute to fire up. So the thing you do with this, when you're working with functions, I keep getting that team message. It takes a minute to fire up. Come on. You'll see the activity down here when it actually gets going. So basically, when you do this, you build a Maven archetype. It's really straightforward. If you just search on Azure Functions Java, you'll find the instructions for that. And basically, you download a Maven plugin. The Maven plugin actually runs and fires up an interactive menu, a wizard, if you will, to actually start building your Maven archetype. It asks you what the name of the archetype is and a few other things. It's not as exciting as this demo. So basically, what that does is it gives you a blank framework to actually build. It's a blank hello world framework to actually build your app. And that app basically starts right here where it says public class function. What I've done is I've gone ahead and I've actually built a Cosmos DB cognitive services function on top of that basic archetype that gets generated, the little hello world thing. So the function name is analyze, and basically I use computer vision to analyze a picture that I load into blob storage. You can ignore that. That's a debug message. The actual app is working fine. So the first thing we do is we set up a trigger. Okay, the blob trigger in this case looks for images in a blob storage container called images. Let's go to our storage, and I'll show you that. So basically, storage accounts. How many people use Storage Explorer before? Okay, a few of you, cool. So Storage Explorer, if you search on that, this is a really cool tool for actually working with storage applications. In this case, I've got a storage called Devox 2018. It's got images in it, or in this case, it has no images in it. So it's a blank storage account, but my function is actually watching in images to see if there's a new image. Once I've got that done, it actually triggers anytime there's a new image. So I've bound to my storage account, and then I've got a trigger that says anytime there's a new image, do something. And what do we do? In this case, we bound that task to Cosmos DB output. It's going to write a document. And in that document, it's going to go out to a cognitive services API, analyze the photo, and bring back certain traits about that photo and put them into Cosmos DB. So let's just fire this up. This is what it looks like. It's on GitHub as well, but it's sitting here waiting. What I do is I go in here and I say upload. This is why I like to use storage. It's really good for demos. All right, let's see. I'm going to pick the Java on Azure logo, as you can see. I upload that, so it's actually going to put it in storage. And let's watch what happens here. Okay, it's just sitting there waiting for a blob to be stored. And in a second, it should actually trigger. There we go. It was triggered. The trigger actually analyzed the document, analyzed the photo, and generated a Cosmos DB document, which is stored in Cosmos DB. And it says right here that it's a drawing of a cartoon character. It's got a confidence of that. It looks like it's got a confidence of 467 that it contains some sort of name. And it's made with vector graphics. So anyway, it just sort of analyzes the photo. I could do another one. Let's see. Upload a photo of me. So let's do a really small one. There we go. Now it's going to trigger that again. Yeah, it's there. Yeah, so there we go. It's triggered that, and it's a picture of a man. It's a person wearing something. So yeah, it basically analyzes the photo for you. So that's just a little example, a simple example of what you can do with a function. And you can deploy this out to Azure, and you can have this running. So it can do things like check to see if there's appropriate pictures being loaded on your website and things like that. This one's a really basic prototype, but it's just the idea to get you started. All right. Oops, pushing the wrong button. So that's build and integrate. So we've actually built something. We've integrated it with Azure services. We built a function, integrated that with Azure services. And now you want to look at deployment options. So there's several different deployment options depending on what you want to do and run your application. Truth be told, most Java shops that I've spoken to are still working with VMs. And they deploy VMs, standard lift and shift. So they start with a VM for their app and a VM for their backend database. They deploy those out to a cloud. And then they start to look at services for actually scaling the backend database and scaling the application itself. And if you're going to do that, then you start looking at Kubernetes and containers. We mentioned 12-factor apps and cloud-native apps. VMs aren't really cloud-native apps. When you get into that, you're sort of refactoring. You build containers. There's a funny saying I heard a while ago. So containers were built to solve problems with microservices. And then Kubernetes was built to solve problems with containers. So the whole idea here is you've got your containers. You build microservices that run on top of those containers. And then you need some sort of orchestration to manage those containers. I'm going to show you an example of doing all this in a while with Azure Container Services. But we have facilities for doing all that. And then you can use some tools like Netflix, open source tools for Hystrix, for back pressure, and Eureka for discovery, and some of the things that Bruno mentioned. Integrate those, and you're actually starting to build a real cloud-native platform now with microservices, containers, orchestration, and back-end services that do things like back pressure and et cetera, et cetera. We have a lot of partners we've worked with this, so Docker, CloudBees, Pivotal, Red Hat, and we have some really common Azure services you can use. When you're doing lift and shift, for example, you use the migrate service. We have Azure VMs. We have Azure VM scale sets. For containers, once you move into that level, we have AKS. We have Azure Container Instances and Azure Container Registry. And I'm going to show a little bit about that in a bit. And then for pure cloud-native platforms, we also have our partners' platforms and ours. So we have Service Fabric for us that manages, the containers and the microservices that run on top of those containers, because that's something you need to manage. And then you have the third-party platforms, Cloud Foundry, OpenShift, and things like that that do this automatically as well. And people generally use those for multi-cloud environments.
Right. So before we jump into a Jenkins demo that you are all familiarized with,
And Kubernetes.
Yeah, I just want to show Azure DevOps one piece of demo because we just announced Azure DevOps is the new name and the new services and the new offerings. And while you can use Jenkins in between, especially for the CI/CD part, actually there's a lot of capabilities on Azure DevOps, especially Azure pipelines already there for you. So we got extensions for Cloud Foundry, we got extensions for Docker, we got extensions for Maven and Gradle and Ant. So you can actually use those common technologies for Java in the Java world within Azure pipelines. So let me show you how that works. And in fact, there is on the Azure dashboard, there is something called Azure DevOps Projects. It's actually really cool to get started because it will use templates and set it up everything for you. So we got this sample, github.com/Azure samples Spring Boot, hello Azure. And this project comes with 2 Docker files. One is specifically for building a Docker image after the Maven project has been built. But the other one is called Dockerfile CI/CD, because this one uses Dockerfile multi-stage build. So basically, it will build the Maven project within the Docker process and then generate a Docker image for you to run. This is the file that you're going to use through Azure DevOps. So we're going to just get the file from the project Git repo. We're going to go to Azure DevOps, and you're going to say, hey, bring your own code, because you want your project right on. We're going to say external Git. So the difference between external Git and GitHub is associated with your account. So if you select GitHub, it will list the repositories on your account and the organizations that you have access to on GitHub. Since I don't want to get that big list that I'm part of many organizations, I'm just going to go and trigger a specific external Git repository that happens to be on GitHub. So I'm going to say next here, and is this app Dockerized? Yes, it is. And I'm going to say next. I'm going to deploy it to web app for containers. And here's the tricky part. By default, it would load the Docker file. But I have that specific Docker file that builds and generates the image. So .cicd. And that's OK. And that's next. And I'm going to create a new organization on DevOps, and it's going to be Microsoft Ignite Java Demo. And in fact, let's make it faster by just doing Microsoft Ignite Demo on an existing organization, because that makes the demo faster. And it's going to be Microsoft Ignite Demo. Interestingly enough, nobody has done a Microsoft Ignite demo yet this week, and the application name is available. That's odd. So let's just say Java, but nobody did. OK, let's do done. It will set by default S1 standard. That's the standard price tier with just 1 core. But if you want performance, you should, at least for Java applications, ideally, because a garbage collector, you should go at least 2 cores for your Java apps. OK, cool. So now this will set up the entire Git repository. It will create a pipeline and deploy the application, build the application, and deploy the application for me automatically. So while this happens, let's take a look at what Brian already has on his environment with Azure pipelines and Jenkins set up.
Sure. Let's see, where's my Jenkins? Here we are. So here's my Jenkins. I've got a few things here. Several hands went up when we talked about Jenkins. How many people use Jenkins plugins for Azure, like VMs, containers, et cetera, et cetera? OK. So one thing you guys should know, actually, ci.jenkins.io. Here's something cool. This is actually Jenkins building Jenkins. And it's actually running on Azure. So when you look over here on the left, Jenkins, we've been working with them for a couple of years now. We actually provide facilities for them on Azure to build Jenkins. And this is tests and things running. It's funny, I was at Jenkins World last week, and when I looked down here on the left, there was nothing running. You know why? Everyone was at Jenkins World. So this week, there's a whole bunch of activity going on. And basically what you're looking at here is when a new PR comes into Jenkins, they automatically test that. They actually load it into a branch. They test that actual PR. They see if it's going to run. They try it on Linux. They try it on Windows. They try it on containers. They run it with Kubernetes. They try a whole bunch of things. And what they're using is plugins in Jenkins to actually do that. And you're seeing over here on the left, here's an Ubuntu Jenkins Kubernetes node right now that's actually testing some things. Here's some Windows VMs that are sitting there idle for a bit. But yeah, there's a lot going on here. So these guys actually use this at scale. It's a great test of our platform and a great test of our plugins as well. But here's an example of a dashboard in Jenkins, and some of the plugins they're using the master agent plugin. So there's a couple of different plugins you can use to run Jenkins master processes that call agent processes. Those agent processes can be on different things. If I go into Manage Jenkins, okay, there's some issues there I got to fix. In my little version of Jenkins here. If I scroll down here, there's a whole bunch of different, they go into the cloud section. There's a whole bunch of different plugins here that are already pre-configured and they run agents for me. This is exactly what you saw on ci.jenkins.io a minute ago. This is what Jenkins does as well. They pre-configure these VMs as agents and they're just sitting there in the configuration that are waiting to be deployed to test things out. So I'm going to go fairly quick here. Just go back to my build. So I actually have a Spring Music deploy task here that I can run in Jenkins. So as I mentioned before, we're all about preserving your investments. We're not going to make you learn something new. Azure DevOps is a really cool tool, and there probably are some times you want to use it, but if you already have Jenkins and you're running it, you can use that as is, put it on Azure, and integrate it with our Azure DevOps tools. So I'm going to show that. Spring Music deploy, basically it just compiles and deploys this to a container. I've already done it several times, and basically it's just a build that runs using a Gradle wrapper that's in the Spring Music. I showed you before in a command line how that actually works. Now let's go into Azure DevOps to show you the actual interesting part. So I've got a Spring Music Lightstep project set up here. As I mentioned, free private Git repos. And what I do for my projects on Azure, I share them. This Spring Music Lightstep is out on my GitHub as well, but it doesn't have all the configuration information, obviously. I don't want to put that out in the public so people can start running things against my Azure services. So I have a free private Git repo here in Spring Music, in Azure DevOps. And in there, I've got all my configuration information, my application properties, et cetera, et cetera. I do the same thing for that functions. So my functions demo that I showed you earlier is out on GitHub, but also I have everything with my computer vision API key and my Cosmos DB connection information in a private repo as well. And as Bruno mentioned, you've got not just repos in Azure DevOps, you've got pipelines, test plans, and you've got boards as well, so Kanban boards and things like that to organize things. The idea here is Jenkins is really great for deploying things and managing and testing and making sure the deployment is done. But how do you actually coordinate a huge project? Maybe you've got a Java app that you want to deploy to a container, and then you've got a C# app that's running on a machine somewhere or an app service. How do you actually make sure that the Java app that connects to a database using JDBC is actually running before you actually try to test your application that's running in C# on a web app? You can do that through Azure DevOps by controlling, using pipelines and test plans. The other thing, so I'm going to show pipelines right now. And of course, you've got Kanban boards where you can actually plan and delegate things. So this is the actual task here. If I say edit, what it does is it actually queues a Jenkins job, which is that Spring Music deploy that I showed you earlier. So it actually triggers that job from here. So the point is, you can set up an Azure DevOps project with a whole bunch of different things and Kanban boards and all kinds of stuff here. And then you can still use all the Jenkins that you already have by just triggering things there. So how do you actually do that? You queue the Jenkins job. I've actually got a pre-built Jenkins service endpoint named Brian's Jenkins, which connects through SSH keys out to my Jenkins deployment so it's secure, and then returns, once that Jenkins job is done, it actually downloads the artifacts and puts them into an Azure container for me. So you can do this through Jenkins, or you can do it through Azure DevOps. And I'm, for this example, doing it through Azure DevOps. So let's see, go back here. And I'm just going to queue this. And basically, it'll run, and it'll go ahead, and it's going to do a manual build for me. Obviously, you can trigger these builds as well and coordinate them. The Kanban board, when somebody finishes a task in the Kanban board, it'll trigger this queue that goes out and runs a test and things like that. So that's just one way to do it. And basically, let's go into this, and let's just see. There's an agent running for this job, and it actually shows you the command line here and shows you the whole thing running. It takes like a minute. So it actually runs, it connects to Jenkins, it actually runs the Gradle wrapper build, does a whole bunch of stuff, blah, blah, blah.
Yeah, the interesting part is we know many companies who have even created custom Jenkins plugins.
Right.
And if you try to if you wanted to adopt Azure pipelines without Jenkins, you cannot simply migrate those Jenkins plugins into Azure DevOps. You have to keep Jenkins environment and then do this integration between Azure pipelines and Jenkins, so you can leverage those existing plugins and configurations, because we know it's a lot of trouble.
Yep. So basically what it did after that, it did the compile, so you saw in the command line there. Then once it was compiled, it was succeeded. Only if it succeeds will it proceed. And then it actually deploys that out to a container instance called builds that goes there. So that's basically the Jenkins part of this. I did want to show you a little bit more about Kubernetes as well.
Yeah, let's just finish on the Azure DevOps.
Okay.
Because for greenfield applications that you feel like, no, it's a basic Spring Boot application or a microprofile application or drop wizard application or whatever kind of Java microservice framework application that you're starting a new project and you feel like, no, we are going to go down with Azure DevOps. We're going to start new projects without Jenkins because we feel comfortable with Azure pipelines. This is the result of that Azure DevOps project created. And it started actually 11/29, and it was done very quickly. The image was created, it was published, and it was released, deployed into production or my environment. So this is the sort of template that the Azure DevOps project creates, and it's actually really simple for Java applications if you have the multi-stage model. If it's just a Maven project, it will recommend you a Maven template on Azure pipelines. It's also simple, and then you can deploy to Azure Web App for Containers or on App Service, or use that WAR file and deploy. Then you customize later, but you can deploy to an existing application server or a Tomcat running on a VM or of any sort. This is just a view that you have, and the application should be live now on Azure App Service Web App for Containers, because this is a Docker container application. Now, because this is the first request, the application on App Service usually goes standby and starts. So the other demo was also on App Service using application insights, and some of the things that we feel like you really want to get monitoring. You have this cloud application, you have to scale, you have to measure performance and metrics and requests. So as we mentioned before, you have access to the Spring Starter for application insights, and you literally have to do two things only. One is add the dependency of the application insights Spring Starter on your project. And the second thing that you have to do is add the key, the instrumentation key, and the name of your application insight instance on your application properties file. So that's what we got here: Azure Application Insights and Spring Application Name, and the application insight key. So with that, we have the application running on App Service, It's the version 3 of my demo.
By the way, Bruno was putting this together while I was talking just earlier. I was having some problems with this, and I think what I was having problems with in App Insights actually was I didn't have enough activity going, so it showed as flat on my App Insights. I'm like, well, this is showing no data. So Bruno actually knew more about it and tried this out, and anyway, he can show you what he did. Yeah.
So this is the very first application that I deployed through Azure DevOps. So Microsoft Ignite demo Java, and there's a simple Spring controller that says API hello. That's okay. And this is the Spring Pet Clinic that has application insights configured. So what we can do is now go to Application Insights, select Pet Clinic, and we already have some data of what's going on with this application here.
One thing I just want to mention that's really cool about this is all Bruno had to do was add those instrumentation keys. All this is standard free included insights, automatic. Yeah.
So if you are in the Java world for long enough, you probably know this little project over here. It's called JMeter. So you can quickly create a thread group, provide some actions, and then simply, bombard your APIs and check for performance and results. So what I do have here is a Pet Clinic HTTP request to my endpoint. So it's Pet Clinic 3 on Azure websites. I'm going to do a search for owners. I'm going to search for last name Brian. The result will be 200 because the application will give a normal message, owner not found, instead of a 300 or 400, 404 or whatever. So the status will be 200. So let's just stop over here for a second and start over again. And let's go to Spring Pet Clinic and let's take a look at live metrics. Hopefully everything will work and you're going to see some things, some interesting charts. Or at least some activity, or no activity at all. It could happen as well. Oh, there you go. So we see some data showing up now. So incoming requests, how long they are taking, the health of my application, how much CPU is being consumed on that instance, and a couple other information that are just dots in my chart. And this one is the duration of those requests, so about 500 seconds or milliseconds. So this is just how simple it is. You have your microservice, you deploy it, you can use Jenkins, you can use Azure DevOps, and you got all these metrics for granted just using Spring Starter.
It's great.
So let's take a look at Kubernetes and how these things will work on that environment.
Right. So as you recall, I built using DevOps and Jenkins a container. So we've got that container now. It's got Spring in it. We know it runs because we did a test in Azure DevOps. So how do we actually get that running on Azure at scale? And the answer there is Azure Kubernetes Service and Azure Container Registry. So first of all, Azure Container Registry. How many people here are familiar with Azure Container Registry? Okay. How many people are familiar with Docker Hub? Okay, quite a few more. Okay, so the idea here is Docker Hub is public. At a free level, you can have one private Docker Hub image. But if you want to actually have secure private registry where only certain people can access your data, you actually need to build your own private registry, or you can buy one. In this case, Azure Container Registry is our solution to that. And it's secure. What I've got it secured through SSH, and it accesses the repo in the storage that I built. And all I needed to do to create that was ACR create, and I've got some environment variables here with a basic SKU. And then the next one, to run that, actually you've got your registry now. You're going to put your Docker images into the registry. Now you need to put them somewhere to actually run them. And we're going to have an orchestration platform called Azure Kubernetes Service, which basically allows you to manage multiple nodes, start nodes, update nodes, replace them, et cetera, et cetera. So to do that, I just had to say AKS create resource group. Now I'm going to do something kind of cool here for this demo. How many people are familiar with Azure Shell? Okay, a couple of you. All right. So this is a good thing to know. Let's see. There we go. Hey, it's still working. Sometimes it logs me out when I talk too much. It times out. So this is Azure Cloud Shell, shell.azure.com. All right. And I've got an application that I've actually built, and it's stored on here. When you use shell.azure.com, you log in with your subscription on Azure, and it gives you 5 gigs of storage automatically that you can use as part of that in the Cloud Shell. So one of the cool things, if I type code, hey, Visual Studio Code in my Azure Cloud Shell. This is not on my local machine. This is out in the cloud somewhere. I have no idea where. I can log into this from anywhere. I can log in from that dodgy computer in the hotel lobby, wherever I need to. There's also a phone app that runs on Android and iPhone that you can use to access the command line. And if I go down here, I actually loaded some code here that I'm going to work with today. This is the Spring Music Light step. I went out to Git. I did a Git clone. I brought it in here. So now I'm actually going to work 100% in the cloud for doing this demo. This is not on my machine at all. But to do that, here I am in Visual Studio. What I do is I do Control-P, and then I say bash. So open bash in Cloud Shell. What this is going to do is request another Cloud Shell for me. And here I am in my shell, so I just went out to my shell, but I'm actually on my local machine. And the reason why I did that is I've got a bunch of different commands I want to show you down here. So let's start with that. Let's just lower this a bit. All right, so I'm going to set up a bunch of environment variables. So I already created the AKS and the ACR, and I've got an application sitting in ACR, but I'm going to build it again using a new tool that we have, which is the Azure Container Registry Build plugin. So what's going to happen is it's actually going to automatically build and set up my ACR for deployment out to Kubernetes. So let's set up some environment variables. So what I'm doing here, this is on my local machine on the top, and on the bottom, this is out in the Cloud Shell. So I already cloned this. As I showed you before, the code is actually out on the Cloud Shell already, so I got that pre-baked. And then I just want to cd to this directory in the Cloud Shell. There we go. The next thing I need to do is I need to authorize, because I'm using a secure version of Kubernetes, Azure Kubernetes Service, and a secure version of the Azure Container Registry. I need to authenticate those two things together. To do that, you use AZ AKS get credentials, and you use the resource group, and you connect to the Kubernetes service. And that'll take a second. All right, so we have the context now. Now we can actually go down here, and we can use our kube control. As I mentioned before, I already created a AKS service, and it's got 3 empty nodes in it, or at least it should. Let's see what it's got. So kube control get nodes. There you go. There's my 3 nodes. They're ready to go. So I created the AKS service. I've got 3 nodes sitting there. There's nothing on them right now. They're just sitting there waiting for something to happen. All right. The next thing I do is I'm going to, I already built the registry, and I've got the container registry. I'm going to deploy this application to Azure Kubernetes Service. And to do that, I use this. I just use the AZ ACR build registry, container registry, and the container. So I went and in my environment variables, I set up the container already. So it's getting that container that I built with Azure DevOps, and it's actually sending the context out to my ACR. So this sounds kind of complicated, but it actually is pretty simple once you get it started. So you've got the whole infrastructure set up. If you think about it, you've got your Azure DevOps, you've got something building your container in Gradle. Then Azure DevOps is putting that into a container that you can actually deploy from. And it's actually building the tool right now.
So we have 10 minutes left, and we would like to at least open for questions now. And
Oh, okay. Yeah, I'll show this in a minute.
while we
While it's running.
yeah, exactly. So and I'm actually interested in asking some questions for you guys. But first, your questions. Any question or curiosity that you'd like to know? Maybe something that we didn't even show that you'd like to know if it's available or if it's possible. Seems that all NetBeans users are on that side. Eclipse and NetBeans are here. Okay. Yeah, there's a question over there. The instrumentation that I did earlier, if I can do from containers. If I can do containers.
Oh, can you instrument containers, basically?
So the application inside SDK is a Java SDK, so it goes within your Java application. It will provide instrumentation of the Java application itself, whether it's running on container or VM. For information about the container itself, I'm not sure right now, but my guess is no, because the telemetry information that it provides in terms of CPU usage, for example, is based on what the JVM provides. And the JVM on the latest versions, at least the JVM on the latest versions of Java 8, does get the CPU usage of the container, not of the host. That was a change in the JDK, in the JVM, I think by 1 or 2 years ago. So the CPU usage you get, when you see CPU usage on that dashboard on application insights, if the application is running inside containers, it will be the CPU usage of the container itself. If it's running on a VM, it will be the CPU usage of the VM. If you are using an old version of Java, such as Java 7, then that gets trickier, because on Java 7, the support for containers is not there, so the CPU usage that the JVM provides is from the host environment, not from the container. So you have to really know which version is running and how the application is running, so you can understand and interpret the right way that information on application insights.
So just switching gears real quick, I'm going to get back to the implementation setup. It actually created the ACR, it compiled, everything was working okay. So then I actually checked the ACR to find out where the actual entry is, and it's in BBen's ACR/ACR.io, Spring Music v1. Okay, so the next thing I want to do is actually deploy this out to Kubernetes, and I do that using kubectl. I still say kubectl. I know I'm saying it wrong, but I'm not. I'm not saying it wrong. kubectl out to the Azure deployment. So the actual deployment is created, and then you can watch the deployment right here. It takes a couple of minutes to get out there. So there we go. It's sitting there. It's actually up to date. It's available. Everything's working. I have to remember to hit Control-C. So it's actually sitting there. All the deployments are there. Control-C. All right. The next thing I want to do is I want to actually deploy the service. Oh, actually, no. I want to do this. I want to watch this, and what it's going to do is it's actually going to sit there. Tell me when it's working. Everything's available. Good. All right. Next thing we're going to do is get pods. Actually, no, let's not do that. Let's set up the service. We're actually going to set up the service here. The service actually deploys a load balancer in front of that. So the service is created. And then we get the service and we watch that. And the reason why we're watching this one is we want to see when this external IP shows up. When the external IP shows up, that means we have a 3-pod Kubernetes service deployed from ACR, and it's actually going to be available on the web. It'll show up as soon as it does. Usually takes a minute or two. And as soon as that's ready, the actual service is ready with a load balancer in front, 3 nodes on the back, and it's all been deployed by ACR. So it just takes a sec to get that going. So while this is going, actually, I wanted to show you something. Bruno did mention the Docker file. So the Docker file itself, it's kind of cool. It's what's called a multi-stage Docker file. It's a common way to do this. So we're actually using JDK8 to build the Docker file because it has a lot more facilities for compiling and building. And then when you run it, you need a much leaner set of functionality. In this case, we could use something that was really lean called OpenJDK8 Alpine to actually make that work. All right, it's taking a while to get that external IP address. There we go. Okay, so now I can go to this IP address. Just complete the loop here. So we've got a full infrastructure running. We started with something on my local machine that connected to Cosmos DB, and then we ran that same thing through the Jenkins DevOps pipeline, made sure everything's okay, it can run tests and things like that. We built a container. Then we took that container, we put it into an Azure Container Registry privately, and then we deployed that container out to Kubernetes service, and that's what we've got now. So you've actually got the same thing running here on Kubernetes now locally. And one of the things I want to show you here, this is out on GitHub. If you look on my repos under bbenz, there's a file called containers.md, and it has not just the demo I showed here, but actually the whole infrastructure set up for creating the AKS, the ACR, building the pipelines, and also as well doing all the things I just showed you with deploying to ACR. I think that is the demo. That's what I wanted to show you. As I mentioned, it's out on GitHub, and you can use the script and everything out there as well.
All right.
We've got a few more slides. We can talk about some case studies and things. I don't know how much you want to cover, but
yeah, so
it's out there too.
Just to mention, JAT is a company that is using Cosmos DB. I think the most important feature of Cosmos DB is the replication, the global replication of the data. It's very easy to set up through the dashboard, through the command line, and the applications, it's transparent for them. Here's just an idea of an architecture of using Event Hub. Is that Event Hub? That is Event Hub.
Yes,
right?
yes, this is Event Hub, yes.
Yeah, how Event Hub connected with Azure Functions and Cosmos DB, you can scale that processing and then just pay for the functions and the execution of those functions very easily. And that supports, Event Hub also has bindings on Azure Functions, so you can combine Azure Functions, you can combine Event Hub processing events and then storing those that data that you process using Java into Cosmos DB.
Yeah. And that's how they do it. They scale Cosmos DB, they scale their event hubs, functions auto-scale, so it's an easy way for them to build a sort of loosely coupled 12-factor cloud-native application using completely built-in Azure tools.
And these are some of the other Java case studies that are running on Azure. So these companies are using Java and are using Azure services in several degrees, several types, several different architectures. So if you want to take a look at what they are doing, you can check that URL and search for the company, and then you can find their story. Okay, so that is what we had, but we want to give you some links so you can snap a picture and follow later for more information. There is a lot that we continue to work on, especially on the documentation side. So if you go to docs.microsoft.com/java/Azure, that's where you're gonna land on the page that we administer and working with the documentation team provide you a nice landing page to find the directions to specific Java capabilities on Azure and also at Microsoft in general. One thing that we didn't show, but Microsoft Graph API has a Java SDK as well.
Oh, yeah.
So you can integrate that with Outlook and other Office 365 services. So all of that, again, on GitHub, open source, and there is a forum, there is a tech community site that you can discuss about the usage of these API, this SDK. And the SDK will work with Azure Functions, Java, with Cosmos DB SDK, Event Hub SDK, whatever you need to integrate, you can combine them in one single project. So if there's no further questions, no questions? Or yes, there is one question over there. Yes. So the question is, if you are building using Docker multi-stage build, it will download the Maven artifacts all the time. That is true. There are ways that you can customize your Maven setup to use a mirror. So you can set up a VM on your Azure subscription, have a mirror of Maven Central or whatever repository. So you can use a Sonatype Nexus or JFrog Artifactory and point to that repository on your Maven settings.xml. So the download will be much faster because it's going to be on your own network, on your own VM environment on Azure. Yeah.
I didn't show that, but there's a ton of extensions in Azure DevOps, and one of them is JFrog. There's a bunch of different ones. I showed the Jenkins extension, but there's dozens of other extensions as well that you can use automatically.
Question?
You have to set up, if you're using a third-party artifact tool like Artifactory, you have to set up your own implementation.
But there is an artifact repository on Azure DevOps as well that you can use. But for Maven, mostly for Maven people, they prefer to use Sonatype Nexus or Artifactory from JFrog.
Mm-hmm. Yeah. On a VM, probably? Yeah.
You can.
Yes.
Azure Artifacts. That's where you can host your artifacts.
You deploy it as a standard endpoint, like a container, or and then Artifactory can pick it up from the container, or I believe there's an extension as well that goes directly to Artifactory. Hey, I just want to say one quick thing. Please do follow us on Twitter, and don't forget your evaluations. I appreciate that.
All right. Thank you so much. We can ask questions later.
Yeah,
Thank you,
we'll
thank you so
for
much.
questions.
Appreciate
Thank
it.
you.